Welcome to MyProjectBazaar.com.
Now we are going to discuss about the product Adaptive Solitary Pulmonary Nodule Segmentation for Digital Radiographic Images based on random walks and sequential filtering. Now we are going to discuss about the abstract for the process. Firstly, the lung image is taken from the collected dataset to solve our objective of the process. Secondly, the seed selection tactic is to enhance the scope of the working pixels and decrease the number of seeds, hence which could decrease the computational time and then the computational complexity of the process. Lastly, we join the sequential filter and construct the novel demonstration of the weight and then the probability matrices. This process is about to analyze the various pulmonary node, that is the affected cancer node in the lung regions. Hence it will segment the cancer regions by using the MATLAB implementation as per the concept of the 3 steps like segmentation, feature extraction and classification. We can able to segment the region of interest, that is the affected regions, and then identified the input lung nodule is the affected or not. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the flow is subdivided into 5 modules. First one is the input, then the second one is the pre-processing, then the third one is the image enhancement, then the fourth one is the segmentation, at last the fifth one is the performance. Hence the input image is taken from the dataset. The dataset is the folder which consists of the several images with the lung nodules. After the getting input image from the dataset, the pre-processing was carried out by the 2 steps. The first one is the image resize, then the second one is the image denoising. Image resize is nothing but to resize the image into an aspect dimensions. For example, the input image consists of the various dimensions, means after the resize, the resized image will be the particular dimensions like 256 cross 256. After the image resize, the image denoising will be produced to reduce the noise present in the image. After the denoised, the filtered image will be the output for the process. After the filtering, the image enhancement is carried by using the contrast enhancement techniques. Hence, this process will be more efficient to identify the lung regions more effectively. After the image segmentation, image enhancement, the segmentation will be carried out. In this segmentation step, the lung nodule regions will be segmented along with the affected regions. After the segmentation part, the performance will be evaluated. Hence, the performance will be evaluated by means of the 3 parameters like precision, recall and F measure. By using these 3 parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the code, means just right click in the main file.m and select the option run. Now you can see the folder dataset. Open the folder dataset and select any one image from the dataset. After the selection of the image from the dataset, the process was done automatically. Hence now the results will be shown like this. In this contour region, you have to select the seed points from the image. Now the final segmentation will be done. It will take some time to execute for the modules. After the final execution, I will discuss the results one by one. Yeah, now the process was done. I will discuss the results one by one. First of all, the input image, that is the figure 1, shows the input image which I have taken from the dataset. After taking the input image from the dataset, the pre-processing is carried out. Hence the anisotropic diffusion, that is the filtering, is done initial filtering is done by using the anisotropic filtering method. After that, the resized image is shown in the figure 3 with the title resized image. After getting the image resized into an aspect ratio, the noise filtering is done as well as the Gabor filter feature extraction was done. Now the segmented results, that is the initial segmented results, will be like this, which is presented in the figure 5. Then the transform of the segmented image will be shown here. Hence the black regions will be the eliminated regions, white regions will be the extracted region of interest. After that, the contour region is shown here. After extracting the seed points from the contour regions, the lung nodules will be extracted like this, which is shown in the figure 8. Hence the lung nodules will be in the zeros, that is the black form, and then the other regions will be the white, which is represented as a background. Now the feature extracted from the lung nodules by using the LBP feature extraction, that is the local binary patterns. After that, the Gabor feature extraction is applied. Hence the Gabor feature images will be shown in the figure 10 and figure 11. Now the geometrical features will be applied. Hence those values will be plotted as a tabulated format. After that, the final classification was done. In that classification, the message box will be displayed as whether the input image is the normal or abnormal. At last, the final performance will be displayed in the figure 3 by using the parameters like accuracy, sensitivity and specificity.
Thanks for watching this video.